Have you ever actually stopped to think about how a computer reads? Because the crazy truth is, when a computer looks at text, it's really just looking at shapes on a screen. It doesn't inherently know what any of it means. To a machine, our words are just pixels and squiggles. Well, I'm Techie from AI Tech Hub, and in today's explainer, we're going to fix that. We're diving into natural language processing, or NLP. This is essentially the entire toolkit that turns those empty shapes into something a machine can actually process and understand. So let's break down the 5 main techniques doing all the heavy lifting behind the scenes.
All right, jumping right into section 1, what it actually is. So NLP stands for natural language processing. At its core, it's the field focused entirely on getting computers to work with human language, whether that's written or spoken. And the key thing to remember here is that we're not just talking about a machine storing text in a database or popping it up on a screen for a user to read. Oh no, NLP is all about grasping the actual structure, the meaning, and the true intent behind those words well enough to actually do something useful with them. And most NLP tasks follow a really clear, linear journey to make that happen. First, raw text comes in. That could be a sentence, a massive document, or just a quick text message. Step 2, that text gets broken down into smaller, much more manageable pieces. Then comes step 3, which is where the magic really happens. Those pieces get converted into numbers. Why? Because a model can literally only work with numbers, not raw text directly. And finally, step 4, the model takes those numbers and uses them to do a useful task, like classifying the text, extracting key info, or generating a brand new response. I want you to keep that 4-step pipeline in the back of your mind, because every single technique we're about to cover in this explainer is a real specific piece of that exact puzzle. You're going to see exactly how we move from raw words all the way to pure mathematical understanding. Moving right along to section 2, the main techniques. We're looking at 5 core techniques today, and each one solves an entirely different part of our pipeline. Technique number 1, tokenization. This is genuinely the very first step in almost every single NLP system out there. It's basically the process of taking your raw text and chopping it up into smaller pieces, which we call tokens, so a model can actually start processing them. Depending on the specific method you're using, a token could be a whole word, maybe just a part of a word, or even a single individual character. Next up, we have embeddings. Now, if you caught our previous embeddings explainer, you'll recognize this. It's the exact same core idea, just applied directly to language. Taking over right after tokenization, this technique turns each of those tokens into a list of numbers that actually captures its real meaning. Mathematically speaking, words with similar meanings end up getting positioned with similar numerical values. It's an absolute game changer because it lets a model work with real context rather than just matching identical words like some basic search bar. All right, so now we move from the foundational setup into actually extracting real value, starting with named entity recognition, or NER for short. This technique is all about scanning text specifically for real-world entities. We're talking about pulling out things like people's names, specific locations, organizations, or dates. But here's the cool part. It doesn't just find them, it correctly labels what category they belong to. So you can have an automated system pull the company name, a specific date, and a dollar amount right out of a super messy, unstructured paragraph. Our 4th technique is sentiment analysis. And man, this one is incredibly powerful for automation. It figures out the actual emotional tone behind a piece of text. So is this message positive, negative, or just neutral? This is exactly what powers systems that can automatically flag angry customer reviews or track the public's reaction to a new product launch, all without a human having to read a single message. Pretty wild, right? Finally, our 5th technique is part of speech tagging. This one does exactly what it sounds like. It identifies the actual grammatical role each word is playing in a sentence. Is it a noun, a verb, an adjective? I know, it sounds super simple, maybe a bit like middle school English class, but it lays absolutely crucial groundwork, because knowing whether a word is being used as a noun or a verb completely changes what that sentence actually means to a computer. Now, if you're sitting there thinking of these as isolated, totally separate tools, it's time to shift that perspective, because they actually build on each other progressively. Tokenization always happens first, to get our pieces. Then embeddings follow by turning those tokens into numbers. And once you have that solid mathematical foundation, well, named entity recognition, sentiment analysis, and part of speech tagging all operate right on top of those embeddings. They're just pulling different, highly specific insights from the exact same underlying data. Let's see how all this comes together in a real-world scenario. Imagine a company wants to automatically process incoming customer support emails. First, tokenization and embeddings take that raw, messy email text and turn it into processable mathematical data. Next, named entity recognition scans through those numbers to pull out exactly what products they're talking about and their specific order number. At the exact same time, sentiment analysis flags if the customer sounds genuinely frustrated, which ensures the urgent cases get bumped right to the front of the line. And finally, part of speech tagging steps in to help the system parse out what is actually being requested versus what is just background story. Boom. We just watched 4 completely different analytical techniques come together to form one real, complete pipeline. And honestly, the best part? They're all working simultaneously on the exact same original email to build a multi-layered, highly accurate understanding of what the human actually wanted. Let's take a second to recap what we've learned today by looping back to our core quote. NLP is the toolkit for getting computers to actually work with human language, not just store or display it. I mean, think about the incredible journey we just took. We started with nothing but raw, empty shapes on a page. We broke that text down into tokens. We turned those tokens into meaningful numbers using embeddings. And from there, we used specialized tools to extract whatever specific information our task needed, whether that was real-world entities, emotional sentiment, or grammatical structure. Yes, it's 5 distinct techniques, but they all share one unified goal. And there you have it. That is NLP, and the 5 main techniques doing the heavy lifting to finally bridge the gap between human communication and machine understanding. I'm Techie, and before we go, I want to leave you with one final, kind of provocative thought. If an AI model's entire understanding of the world starts with exactly how it breaks down words, how much does changing that initial tokenization process change the AI's baseline intelligence? Really think about that for a second. If you want to dive deeper into that rabbit hole, comment NLP right now for our full breakdown on tokenization, since it literally is the foundation everything else builds upon. Make sure to subscribe for more explainers just like this one, and I'll see you in the next one.